So are we done with all of mechanics?
No, we are not done.
So why don't we just finish off mechanics and then start materials like the school's doing?
Because I feel like if you do materials first, you understand mechanics better. Whereas the reverse is not true. So I actually think it's much better to start with materials. Not finish materials, but start materials until you do the lesson on viscosity. So like 2 lessons after that, then return to mechanics, then return back to materials. I just feel like this is the best way to teach it. But regarding mechanics, we basically did the 2 main topics, which is vectors and SUVAT, constant acceleration. So yeah, we'll return to mechanics later. Okay, so upthrust and viscosity. So here's your spec point. So this is from the spec 24. Understand and how to use the relationship upthrust is weight of fluid displaced, and also understand what is meant by the term viscosity. So that's what we hope to accomplish by the end of this lesson. A quick recap. What is density based on?
Density is the mass per unit volume.
Excellent. Joanne, calculate the density of a cuboid with length 5 centimeters and mass 450 grams. Give your answer in kilograms per meters cubed. So this is like a multiple step question. So yeah, all of you have a go at question 2. Hello, Isa.
Hi, sir.
So would the answer be 0.09 kilograms per meter cubed?
Let's have a look. So obviously density is mass over volume, which is 450. That's the mass in grams, and the volume is 5 cubed. If you put this into your calculator, so 450 divided by 125, you get 3.6 grams per centimeter cubed. But it wants the answer in kilograms per meter cubed. So to go from grams to kilograms, I know I need to divide by 1,000. And to go from per centimeter cubed to per meter cubed, what must I do? Isa, do you remember?
From centimeters cubed to meters cubed, you divide by a million.
Good. From centimeter cubed to meters cubed, you divide by a million. But in this case, this is per centimeter cubed. So you have to times by a million instead. So yeah, you do 3.6 divided by 1,000 times by a million, and then you get your answer, which I believe is 3,690 kilograms per meter cube. I just did this in my head. I'm not too sure. Okay, derive the SI units for energy. Let's have Muhammad.
So for energy, could we use the energy as in gravitational potential energy, which is mgh.
Okay. So what do you get?
So For mass will stay the same.
What's the unit for mass?
Grams, no wait, is it grams?
Kilograms is the
Kilograms.
standard unit. What's the unit for G?
For gravity,
Yeah, what's the unit for gravitational fluid strength?
is it newtons?
Nope,
I'm
It's-
not sure.
meters per second squared. And what's the unit for height?
Meters,
Meters. This becomes kilograms meters squared, because that's meters times meters, s minus 2. So yeah, you could use gravitational potential energy. You could use kinetic energy to help you, which is half mv squared. Half doesn't have a unit, so you ignore it. Mass has the unit kilograms. Velocity has the unit ms minus 1. But velocity squared will have the unit meters squared s minus 2, right? Because this is meters times meters and s minus 1 times s minus 1. So this is just a rule for math. So this becomes kilograms meters squared s minus 2. Or you could have even used the equation for work done. Work done is force times distance. And force is mass times acceleration. So this becomes work done is mass times acceleration times y distance, which is kilograms meters per second squared meters, which is kilograms meters squared s minus 2, or per second squared. Does that make sense? All three equations allow you to arrive at the SI units. Okay, so let's continue this lesson. So recap from GCSE, Archimedes principle. I'm sure you all remember this. And he basically said that if you fill a container with a liquid all the way to the top, and you place an irregular object, the liquid is going to overflow. And the volume of liquid displaced, i.e. the volume of the liquid that has overflown, is the exact same as the volume of this irregular object. So we could use this method to work out the volume of irregular objects, because maybe something like a rock, you can't really use a formula for it. You can't do 4/3 pi r cubed, because a rock is not exactly a sphere. So you know that's the only method we have to work out is volume. So the volume of water displaced is equal to the volume of the object. Okay, now I have a question for you all. Why do objects float in water? Not all objects, but some objects. Why do they float in water? Yes, Joanne?
This is due to the density, say?
What about the
Like,
density?
let's say objects are less dense than the liquid are gonna float in that liquid.
Okay, so less dense objects float. Excellent, that's true. But I guess my question is, why do less dense objects float to begin with? What causes something to float?
Upthrust.
Excellent, upthrust. This is the key. It's a force, because everything has the force of gravity pushing down. So the natural thing is for objects to fall. That's the natural thing. Objects should be falling. But if an object doesn't fall, that means there is no resultant force acting on the object. And I know that weight acts on every object. You can't escape that. So if there's weight going down, there has to be an equal force going up, so you could have no resultant force. And only when you have no resultant force, the object will float. So why do objects float? Is because there's a force pushing it upwards that counteracts gravity, and this force is called upthrust. Good, so upthrust is defined, and I want you to copy this down. This is the definition from your spec of upthrust. Not this one. The definition is about to come. So no, upthrust is the upward force that fluids exert on objects. This force opposes weight. So we said it's an upward force, and fluids like water will exert this upward force on an object. It opposes weight. It's in the opposite direction of weight. and is defined as the following. So copy this definition down. Upthrust is the weight of fluid displaced. What does that mean? We'll come to that later. Hopefully by the end of the session, you understand this definition of upthrust. Upthrust is the weight of fluid displaced. Weight being the force of gravity equal to mass times g, mg. All right. So let's define or let's derive upthrust. Let's assume,
Sir,
yeah.
so do you mind going back to what upthrust means, like the previous slide, just so I can write it down very quickly? Thank
Oh,
you.
sorry, yeah. So this definition is going to come in handy for so many different types of questions in A level. And it's combined with mechanics as well. So lots of mechanics questions involve this force of upthrust.
Okay, sir, I finished.
Okay, so let's say you have a cylinder. So let me draw a cylinder. And it's submerged under a fluid. Let's just say, I don't know, water. Water is the fluid. So here's my cylinder. And my cylinder is underwater. What forces are acting on my cylinder as it's underwater? What are all the forces acting on the cylinder? Anyone want to name a force?
So I think water resistance isn't.
Water resistance? Potentially, okay. So if it's moving, I guess. So if it's moving, then there's water resistance. If it's not moving, then I guess there's no friction, there's no water resistance. Any other forces?
Upthrust and gravity.
Upthrust and gravity, excellent. Okay, what causes the upthrust force, or what causes the forces on the cylinder? Well, there's water molecules, thanks to the water. These water molecules are moving randomly, just like air molecules move randomly. And as they're moving, they collide with the surface of the cylinder. And when they collide, they exert a force. The momentum of the water molecules change and they apply a force, because I know that force from last lesson, force is defined as the rate of change of momentum. So as your water molecules collide with the cylinder, like let's say the water molecule is going to the left and it collides, now it's going to go to the right. The momentum changed. If the momentum changes, it means obviously a force is exerted. So these water molecules are exerting a force on the cylinder in all directions because the water is colliding in all directions. So water is colliding to the right, applying a force to the right, and it's also colliding to the left, applying a force to the left. However, the forces going to the right are cancelled out by the forces going to the left. Because let's say you have 10 newtons applied to the left by the water molecules on the left, you're going to have 10 newtons being applied on the right. Why? Because there's the same surface area exposed to the water. You have the same number of water molecules colliding on either side. So this force kind of like cancels out. So we don't care about the forces acting on the left and right because the resultant force is 0. There's still mg though. Mg still acts on the cylinder. But now let's talk about the force acting on the cylinder due to the water molecules up. So the water pushing down and also pushing up on the bottom. So on the top, you have like a circle, a surface area, the surface area of a circle, and the water molecules is touching this and colliding in this surface, and it's also touching the bottom and colliding on the bottom. Now I have a question. Is the force exerted up greater than the force exerted down by the water? Or is it the same? So remember I said there's water colliding with the top surface, applying a force. Is that the same as the force colliding with the bottom surface? Or is it different?
Sir, would it be the same, but like, do we consider that this cylinder is inside of the water or is it floating?
It's inside the water, submerged fully.
So there's more on the top than on the bottom, for sure.
So you think there's a larger force pushing up than there is down?
No, like I mean on the top, like the arrows going down. That's where I think the most force is.
Okay, interesting. Anyone else? No one else has any opinion on this matter? Okay, I have a question then for the rest of you. Is there an equation that tells me what the force is acting on an object underwater due to the pressure of the water?
Rho GH.
Excellent, rho GH. So well done, Asa. So I know that the pressure due to the water, is rho GH. I also know that the pressure is defined as force per unit area. So the force due to the water pressure, we're going to say the force is equal to pressure times area. Well, what is the pressure? Well, because we're underwater, we could say that the force is rho times G. Rho is the density of the water. G is just 9.81. H is the depth. So how far you are below the surface. So rho GH multiplied by A. This is the force acting on your surface. So let's just write force. So from force is pressure over area. So force is pressure times area. Put that in brackets. Also pressure is density times G times H. From these two, we get the following, which is force. The force exerted on the cylinder by the water is rho times G times H times by A. A is the surface area, right? Because pressure is force over area. So A is going to be the surface area of the cylinder, which, you know, is a circle. So it will be pi r squared. So we'll talk about that later. Okay, so excellent. This is the force. Now I know there's F1. F1, let's say F1 is the force acting on the top surface, and F2 is the force acting on the bottom surface. So what is F1? Let's define F1. F1 is equal to rho, which is the density of the water. That doesn't change. Multiplied by G, multiplied by, let's say, the distance from the top of the water to the first surface, the first cylinder. Let's say that's H. And let's also say that the length of the cylinder, actually, let's use a different color. The length of the cylinder is X. Okay. Well, the depth of F1, the depth of the first surface, the force acting on the first surface is just H, right? It's just the first surface, the first cylinder, the first circle, sorry, is at a distance H. So, and that is and then multiply that by A. That is the surface area in contact with the water. Now, what is F2? F2 is also the density of the water. That doesn't change. Multiplied by G, multiplied by H. H is the depth. What is the depth of the bottom surface F2? Is it also H? No, it's H plus X, correct? Because the bottom surface is at a depth of H, which is, you know, the distance to the top surface, plus X, which is the length of the cylinder. So rho times G times by H plus X multiplied by A. So what is the resultant force acting on my cylinder? Well, the resultant force is just going to be F2 minus F1, because F2 is the larger force. So there's a larger force acting on the bottom surface than there is on the top surface. Why? Because in the bottom surface, you're deeper underwater. And the further below you go, the higher the pressure, the higher the force. So the resultant force, let's call it F res for resultant, is F2 minus F1. So what is F2 minus F1? Well, F2 is rho times by G times by H plus X times by A. That's F2 minus F1. F1 is rho times G times just H times A. Now let's simplify. In maths, if you had this sort of expression, you would want to factorize the like terms. So what do they all share in common? They both share a rho, they both share G, they both share A, rho GA. So let's factorize out rho GA. So this becomes rho times G times A. And what's left of the top fraction is H plus X. Minus, because you're minusing rho GHA, but what's left of this is just H, so minus H. So this becomes rho times G times A times open bracket H plus X minus H. So the H's cancel out, and you're just left with rho times G times A times by X. Times by X. I should have used X. I should have used Z or something else because, you know, times looks like X. So yeah, this is the resultant force. And this resultant force is what we call upthrust. Does that make sense? So there's a force acting upwards due to the water pressure. There's a force acting downwards due to the water pressure. The force acting upwards at the bottom is larger. Why? Because it's deeper under the water. So there's a larger pressure, larger force. And the resultant force is the difference in these two forces. And we just worked out that the resultant force is rho GA multiplied by X. But let's say instead of X, let's say Z. Let's say it's equal to, write it here in green, rho times by G times by A times by Z, where Z times A is the volume, right? Because this is a cylinder. What's the volume? The area times the length. So we could say that this upthrust, this force of upthrust is equal to density times G times by the volume, because the area times Z is just the volume. Well, what does density times volume equal to? What can I equate density times volume?
Mass.
Mass, excellent. So now I could say upthrust is equal to mass times G, because density and volume is equal to mass. So look at this. Look at this. That just shows that upthrust is equal to m times g. Well, what is m times g? Weight, correct? M times g is the weight. So therefore we just proved that upthrust is equal to the weight. And what is this? This is the weight of what? This is the weight of the fluid. Why? Because this volume before was the volume of the fluid displaced. Because this cylinder, if I place it underwater, there's going to be a volume of water displaced, and the volume of the water displaced is the same as the volume of the cylinder. This is Archimedes' principle. So this is the volume of the fluid displaced. This is the mass of the fluid displaced. So I just proved that upthrust is equal to the weight of fluid displaced. This is the definition of upthrust. Raise your hands if that makes sense, what we just did. Okay, excellent, Joanne. Excellent, Muhammad. Excellent, Faizan. Isa, what part were you? Shall I try?
No, I
again?
understand. I understand.
Okay, excellent. So good. We just proved the definition of upthrust that you've written down. Upthrust is equal to the weight of fluid displaced. So every time you're dealing with a question and it involves upthrust, or you just know that upthrust is the weight. So upthrust is the weight, which is just m times g. The question might not give you the mass of the fluid displaced. In fact, it never will, but rather it will give you the density of the fluid and the volume of the object that's underwater. And if you know the density of the fluid and the volume of the object, you know the mass of the fluid displaced. So this is your equation for upthrust that I want you to write down. Upthrust is density of the fluid. Don't get the density confused. This is the density of the fluid, not the density of the object. Okay, so upthrust is density of the fluid multiplied by the volume of the object. Multiplied by the volume of the object. And then obviously multiplied by G. G is just 9.81. Don't need to label that. Good. So this is the equation for upthrust that you'll be using in exams. And it's going to be used in so many creative scenarios, as we're going to see with the following PowerPoint.
Sir?
Okay. Yes.
So it's basically like the definition when you put like an object in a fluid and like you're just finding out, like I don't know how to explain. So you're just finding out how much of the liquid like that was displaced, like how much of the liquid
Yeah.
was the object took away. You know?
Yeah.
I don't know how to
Excellent.
explain.
Yeah.
That's it.
And the weight of that is the same as the force of upthrust.
So the weight of the object.
No, the weight of the fluid displaced. So you remember you said when you put an
Oh.
object, the fluid is going to leak and displace. The weight of that fluid, the mass times G, you know, the force of gravity acting on that little amount of water that left is the same as the force going upwards, the upthrust. So that's what upthrust is. It's the weight of the fluid displaced. So every time you place an object underwater, remember Archimedes' principle from this slide. When you place an irregular object underwater, there's going to be fluid displaced. And the weight of this fluid that's displaced is equal to upthrust. And what is weight? Weight is mass times G, and the mass is the volume. Well, what is the volume? It's the same as the volume of the object, because the volume of the water displaced is the same as the volume of the irregular object. That's what Archimedes' principle is. So it's the volume multiplied by the density. But don't get the density confused. This is the density of the fluid, not the density of the object. All right, excellent. So let's do some questions. Now that we've derived upthrust, by the way, you need to know how to derive it. So exactly what I went through, because they could give you a 4-mark question or a 5-mark question and say, derive upthrust and prove that it's equal to the weight of fluid displaced. You're going to have to do the exact same steps that I did. You don't have to do a cylinder. You could do another shape like a cuboid, but a cylinder is the easiest one to do. So that's why I would advise you do a cylinder. Okay, so let's do some questions. A brick is 24 centimeters long, 9 centimeters wide, 8 centimeters high. Its mass is 3.5 kilograms. The density of water is 1,000 kilograms per meters cubed. Question number 1, work out its density. So work out the density of the brick. Question number 2, deduce whether or not the brick is going to sink. And then finally, question number 3 is work out the initial resultant force of the brick when fully submerged underwater. So when the brick is all the way underwater, what is the resultant force? Which obviously the resultant force is going to be mg minus upthrust. But yeah, have a go at these questions. I will give you, I think, 5 minutes, and then we'll get some people to share the answers. Okay, who's finished?
I finished, sir.
All right, Faizan's gonna walk us through this question.
I got you. Okay. So for the first one,
Mhm.
I did 24 times 9 times 8 to get the volume in cm cubed. And then I divided by 100 cubed to get it into meters cubed.
What did you get?
And my answer was 2025.5 kg meters cubed. It's same thing, yeah. So you just put it in standard form.
Good, excellent. So 2.025 times 10 to the 3 kilograms per meters cubed. Okay, will the brick sink?
Yeah, it's gonna sink because it has a higher density than the water.
Excellent. And what was the initial resultant force?
Okay, so I did 1,000, which is the density of the fluid times the volume of the object, which is 1.728 times 10 to the power of -3 times 9.81, which gave me 16.95 newtons.
That is upthrust. It didn't ask for upthrust, it asked for the
Oh.
resultant force. What forces are acting on the brick when it's underwater?
There's upthrust, there's gravity.
Excellent. You just considered upthrust. The resultant force is going to be gravity, mg, weight. Don't say gravity in exam, say weight. So there's
Okay.
weight downwards and upthrust upwards. You just worked out upthrust. You also need to know what the weight is because the resultant force is weight minus upthrust. So do that, work out what the weight is. What would the weight be?
3.5 times 9.81,
Excellent.
which
What
is
do you-
34.335.
So now you do weight minus upthrust. What do you get?
Which is, so it's 34.335 going downwards because of
Yes.
gravity
Mhm.
and 16.95 upwards. So you just subtract them,
Beautiful. And what do you
which
get as the
is
final answer?
17.385 downwards.
Good, which is 17.4 newtons. So the brick, when it's underwater, there's only two forces. There's mg, down, and there's upthrust, up. Mg is just mass times g, 3.5 times 9.8, and upthrust is the weight of fluid displaced, which is density times volume times by 9.81. But don't forget to convert the volume into meters cubed because the density is given in kilograms per meters cubed. Raise your hands if this makes sense. You know how to do this. Just Faizan, Isa, Muhammad, Juwan. Want me to explain it in more detail?
Sorry, I couldn't raise my hand because I was writing down everything, but I believe I understand. I believe I understand.
Excellent. Beautiful. Let's continue then. So, is it easier to swim in salt water or fresh water? And by swim, I mean float, I guess.
It's easier to float in salt water
Why? Why is it easier to float in salt water?
because it has like a high density, and if you have a lower density than the salt water, you're gonna float.
Yeah, but that's the answer I'd expect you to give me at the beginning of the lesson. Now that we've learned what upthrust is, I want a slightly different answer. Yes, Lisa.
In salt water, there's a greater upthrust.
Why?
So there's a greater force pushing you up, which is why it's easier to float.
Good, excellent, because upthrust is rho times, which is the density times volume times g. The density of salt water is higher than the density of fresh water. So the upthrust is higher because the upthrust depends on the weight of the fluid, right? And the weight of salt is larger than the weight of fresh water. So why is it easier to float? Because there's a larger upthrust force. There's a larger force pushing you upwards. So yeah, always talk about forces in physics to score the marks for your explain questions. All right, let's do this question. A spherical polystyrene bead is immersed in oil. The bead has diameter 4 times 10 to minus 3. The bead is released and moves upwards through the oil at constant velocity. Complete the free body force diagram below to show all the forces acting on the polystyrene bead. So let's have Joanne walk me through what will the forces be acting on this. It's already drawn one force for you, upthrust. What other forces are acting on this?
So it's gonna be gravity.
Good, mg going down. Always draw your vectors from the middle.
And so can you show me the question again? Because I think I have one more, but I don't know, I'm not sure.
Did you find
Is
the
it-
other force?
Is there gonna be the resistance of the oil, like the oil resistance or something like that, like the density?
It is a resistance. This resistance is called friction. Because the bead is moving. Anytime you're moving, there's resistance. If you're moving through air, there's air resistance. If you're moving through water, there's water resistance called drag. Okay. So yeah, is this resistance, this water resistance, is it up or down?
It's
it-
acting downwards
Why downwards?
because it's opposing the direction of motion.
Excellent, because the bead's traveling up and friction always opposes the direction it's traveling. Now, the force diagram I drew is technically incorrect. Who wants to tell me why? Because if you combine the friction and mg, you're going to get like a larger arrow than upthrust. And in the exam, you have to kind of draw your arrows to scale. So maybe something like this. Mg and friction would be more appropriate. In fact, don't call it mg, call it weight.
Sir, in the
Now,
exam, if we
Now the length of these two is around the length of this, I think. Well, I think maybe I should have made it a little bit bigger like this. I think now that's fine. Yes, what was your question?
sir, in the exam, is it okay if we put water resistance, or does it have to be friction?
Okay, there's a different name you have to use. It's not water resistance and it's not friction. It's called viscous drag. And we're going to talk about that when we arrive. So yeah, that force has a name. It's called viscous drag. Okay, now it says, show that the upthrust the oil exerts on the bead is 3.1 times 10 to the minus 4 newtons. So have a go at this question. I'll give you 1 minute. Okay, anyone finished?
So I finished, but I don't know if my method's correct.
Go on, actually.
Okay, so basically what I did is I don't think they gave the volume, and since they gave us upthrust, I just made upthrust equal 9.81 times 930 times V. So then I solved for V, and then I just put V back into the equation to find upthrust, and it was the same. Like that's what like it gives you the answer they gave you.
Okay, rule number one in show that question is you cannot use the answer to get to the answer. That's what you
You
did.
can't do that.
Of course not. No, you can't use the answer at all. The answer is just there for you to arrive at. You can't use it. The second you use the answer in your question, you lose all the marks. So I like how you noticed and you told me that upthrust is density times volume times G. And although you're right, they haven't given you the volume. Have they given you something that could allow you to calculate the volume?
The diameter.
Excellent. It's a sphere. So what's the volume of a sphere? 4/3 pi r cubed. They give you the diameter. That means they've basically given you the radius. So it becomes 4/3 pi brackets 2 times 10 to the minus 3 cubed to the power of 3. That is the volume. The density is 930. So your upthrust is 930. And let's store this value in our calculator as A. So store in your calculator as A. So 930 times by A times by 9.81. Someone do this and tell me, what do you get?
Sir, aren't you supposed to use the volume of oil?
The volume of the
Oil.
oil displaced is the same as the volume of the bead.
What do you mean?
So if you place a bead in a full container, you place the bead, water is going to overflow, right?
Oh, yeah.
The volume of this bead is the same as the volume of the oil displaced. That's Archimedes' principle. So you use the volume of the object. The object is the bead.
Oh, okay. Yes, sir.
Yes. No, I was waiting for you guys. I said do this and tell me what you get as the answer.
So I got the answer, like what they gave you.
No, but I don't want 3.1. I want the full answer.
Oh, I got 3.0 with 3.05103216 something like that.
Excellent. 3.05 times 10 to minus 4. And that rounds to around 3.1. In a show that question, you have to give the full unrounded answer first to at least 3-4 significant figures. If you don't show the examiner you got this 3.051, you drop a lot of marks. So first, every single show that question, give the unrounded answer and then say, oh, that's around, like squiggly line, that's equal to around 3.1. Does that make sense? All right, let's continue. So now let's talk about viscosity. So different fluids have different properties. Would it be easier to swim? And by swim, I don't mean float this time. This time I actually mean swim from like point A to point B. Would it be easier to swim in honey or water?
Water.
Water, right? Why?
Honey's thicker and
Honey is thicker. So why would that make it more difficult?
So I think since it's more thicker, it has a higher viscosity, so it has a higher friction.
Excellent. There'll be more friction opposing you. You're trying to swim to the right, but the friction's going opposing you, saying, get back here. Okay, good. So that's because honey is more viscous than water. What is viscosity? It's a property of fluids. Different fluids have different viscosities. And because it's more viscous, there are larger frictional forces opposing your motion. Remember, in physics, always talk about forces. You always have to talk about forces. So forces are opposing your motion. So what is viscosity? Here's a definition that you need to memorize and use. Viscosity is a measure of the internal friction in a fluid. More viscous fluids contain larger frictional forces. So honey is going to have more frictional forces between each layer than water. And because there's more friction between each layer, it's harder to move through it. Because let's say honey has 1 billion layers, and each little layer is on top of each other. If you're trying to push through the layers, it's harder because each layer has more friction opposing. And here are some questions for us to do. Question 1, a car battery
Wait a second,
contains...
you go back for 1 second. I was copying it down.
Oh, yes. Sorry.
Okay, I'm done.
I'm still not done.
All right.
Thank you.
And then our next lesson, which it won't be Tuesday, because Tuesday I'll be abroad. So our next lesson will be Thursday. So next lesson will be doing viscosity. And after viscosity, we will be doing Hooke's law. And then after Hooke's law, we will be doing materials. And then we are finished. I think I might be able to combine Hooke's law and the other lesson in one lesson.
So that's it.
sir.
Yeah, and that's it.
So materials is really short.
Yeah, it's really short.
Sir, did you do moments and momentum and stuff like that?
I mean, last lesson we did, but like I said, it was very short. So once we
Yeah, okay.
finish, you could have choices. Either we could just end the sessions, like if you're all comfortable, or we could start doing what's it called, tailored past paper questions. So we're doing past paper questions on all the topics, And that's like when you develop the true understanding. Because the problem is like the content in physics is really short. There's not much you need to memorize. There's hardly anything you need to memorize. Most of it you learn in GCSE. The hard part is learning how to apply that knowledge in different scenarios. So yeah, after we finish, we can just do like past paper questions, or you could like end this up to you. But I would say at least maybe try 1 or 2 past paper question sessions so you could feel comfortable. Because what happens most of the time is people finish the content, they do past paper questions, and they can't answer a single past paper question. So they solve one question, they get the answer wrong, they don't know how to do it. They look at the mark scheme and they say, oh, that's how you do it. Then they do the next one and the same thing. Oh, that's how you do it. And it keeps, that process doesn't go away until the exam happens where they're unable to answer the questions. Why? It's because what I spoke about in our first lesson when we were speaking about active recall, spaced repetition, interleaving, reflecting. So by having like past paper sessions, I could like teach you and show you the skill sets. Oh, this is a SUVAC question. I have to start like this. Oh, this question involves variable manipulation. So you have to start like this. Oh, this question involved this word. So I have to use these words. So these are skill sets that you have to start picking up and knowing how to use. So yeah, we can talk about that after we finished. Well, no, there's still, so there's those lessons for materials, but for mechanics, there is still energy, power, efficiency, work done, forces, Newton's laws. So there's still like maybe 2 or 3 lessons left of mechanics, unless you want me to redo the topics, moments and momentum in more detail, up to you guys. Anyway, so here's some questions, some application questions. Treat it like your exam, try your best not to make any mistakes. And good luck, I guess. So question 1, a car battery contains 1 liter. By the way, I want you to know how to convert, oh, it tells you the question. 1 liter or 1,000 liters is 1 meter cubed. 1,000 liters is 1 meter cubed. So the mass is 1.265. What is the density? Well, density is mass over volume. So 1.265 divided by 1 times 10 to the minus 3. And you get 1.265 if you convert properly. So then it says the radius of a bowling ball is 0.11 meters and its mass is 7.26 kilograms. Work out its density in kilograms per meters cubed and grams per centimeter cubed. Then it says estimate the mass of air in this room. You're all going to do this question and we're going to get your estimates. It's an estimate, so you have to like set up some assumptions. So maybe the room has this volume, or the room can be modeled as a cuboid, and the volume is base times height times blah blah blah. So to work out the mass, I need to know the density of the air, which you could get from Google, multiplied by the volume of the room. Then it says a golf ball has a diameter of this. If he hits the ball into a stream, what upthrust does it experience when it's completely submerged? So what's the upthrust? If the mass is 45 grams, what is the resultant force on it when it's underwater? And then finally, referring to Newton's laws of motion, explain what will happen when it's fully submerged. Is it going to accelerate, be stationary, blah, 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 like explain fully, describe the motion. And then finally, it says a ball bearing of mass 180 is hung on a thread. Its density is 800. Calculate the tension in the string if the density of the ball bearing is 8,000. So the density of oil is 800 and the ball is 8,000. What would the tension on the string be? And then finally, estimate your own density. So you're a human, you have a density, it's mass over your volume. How can you work out your mass? And how can you estimate your volume? So I'll give you, how much do we have? I will give you 8 minutes to do all these questions. For the estimate questions, I want like good estimates and like good assumptions.
Sir?
Yes.
Sir, for question 3, it says estimate the mass of air in this room. So in what room? Like, it just says that, doesn't say anything else.
Any room. Any room.
In any room.
The room you're in, basically.
Okay.
It's an estimate, right? It's just an estimate.
So how many marks is the question?
If this was an exam, it would be like 3 or 4 marks.
Oh, so you have to do a calculation. Okay.
Yes. Okay, I think we've had enough time. So let's go through the solutions. So question 1, you should have all got 1, 2, 6, 5. Question 2, the density is 1,300 kilograms per meters cubed, or 1.3 grams per centimeter cubed. Estimate the mass of air in the room. Well, listen, the mass, we know that mass is density and volume. So let's just say I have a room that's 3 meters by 4 meters, and the height, or generally rooms are like around 3 meters, maybe, or maybe not 3, maybe like 2.5 meters. But let's just say 3 meters because it's an estimate, so it doesn't really matter. Then the volume is 3 times 3 times 4. The density, well, the density, what you do is you just go and search the density of air, or it'll give it to you in the question, and just find your answer somewhere. .29 kilograms per meters cubed. So you do that times by 1.29, and that should be the mass of air in the room. Okay, next question. A golf ball has a diameter of 4.27. What is the upthrust? Well, the upthrust is going to be the density times the volume. The density is given as 1,000. The volume is not given, but the diameter is given. So you could do the volume of a sphere is 4/3 pi r cubed, where the radius is half the diameter. Then what is the resultant force? Well, the resultant force is just mg minus upthrust, because those are the two forces acting on the ball once it's underwater. You have weight and upthrust. So what is the difference between the two? And now it says, referring to Newton's laws, explain what will happen to the submerged golf ball. Well, if you look at the answer, you would have got 0.042 as the resultant force. So obviously there is a downward resultant force, therefore it's going to accelerate downwards. So always, from Newton's second law, F equals ma, if there's a resultant force, it will accelerate downwards until maybe the friction gets higher and higher and it reaches terminal velocity, something like that. Because once the ball starts to fall down, before the ball starts to fall down, the only two forces acting on it is mg and upthrust. But as the ball starts to fall down, there's now also friction. And eventually, friction plus mg is going to equal to your upthrust, or because it's going down, friction should be the other way. Friction should be up. So mg, which is the weight, is equal to friction plus upthrust. So as it gets faster and faster and faster, the friction becomes higher and higher and higher until the friction plus upthrust is equal to mg. So it has now reached terminal velocity. And then finally it says, estimate your own density. Well, what I would probably do is I would pretend I'm a cylinder. I would model myself as a cylinder with height 1.8 meters maybe, and diameter, say 0.4 meters. So you could model yourself as a cylinder to work out the volume. And then the mass, your mass is going to be, everyone knows your mass, you just use a scale. So do your mass divided by volume, and that is the estimate of your density. Does that make sense? Raise your hands if all of this makes sense. And if you have any questions, let me know now.
So for question 4, so you have to calculate for the volume. So you do 4/3 pi r cubed, right?
Yep.
So what I did was 4/3 times pi times 4.27 cubed.
That's wrong, because that's the diameter. You want the radius.
Oh yes, you have to have it.
Mm,
Okay. That's what I did wrong. Thank you.
no problem. So you always, when you see diameter, just keep in mind that it's probably the radius that you need. Not all the time, but most of the time. Any other questions? No? How was your exam, by the way?
I don't want to talk about it, sir. It was
Not
so hard.
good. It is. Physics is, like I said, the memory is small, the application is hard. The application
Yeah, and so the
YouTube,
problem,
yeah.
so the problem is like because I wasn't in Kuwait, so I didn't have time to study for it. I come back the next day, I have a test.
Oh yeah, that makes sense. How about the rest of you? How do you find it? Joanne
It
and
wasn't that, it was
It
okay.
was, yeah, fine-ish.
It was okay.
Yeah.
that's good, yeah. Did you what topics came